This is where you will live in the future. Throughout history, humans have made incredible advances in technology. From the invention of writing to the development of agriculture, we have accomplished so much. Yet despite these achievements, we are still confined to our small planet. The dream of interplanetary colonization remains just that, a dream. However, there is hope on the horizon. In the next few decades, we might establish a permanent residence on the Moon. And if all goes well, we could even reach the red planet, Mars. Just imagine the possibilities that lie ahead. But what if I told you that there could be other Earths out there in the vast universe? Planets that are just like ours, or maybe even better. Over the past few decades, scientists have been searching for these exoplanets, planets outside our solar system. They have used powerful telescopes like Hubble and Kepler to make amazing discoveries. And here's the exciting part. They have found planets that resemble Jupiter and Neptune. But even more thrilling is the fact that some of these exoplanets are similar to our very own Earth. One such planet is Kepler 22b, and it is the best candidate to host life as we know it. The possibilities are endless, and who knows what awaits us in the vastness of space. Join us on this video journey to learn more about Kepler 22b. This is where you might end up living in the future. Finding Kepler 22b, the transit method. Finding planets outside of our solar system is not an easy task. Unlike the planets within our solar system, which can be easily spotted with current technology, extrasolar planets are much more difficult to detect. One of the main challenges is that these planets are much smaller than their parent stars. They are just a fraction of the size and mass of the star they orbit. This makes it incredibly hard to directly capture an image of an exoplanet, even with the most powerful telescopes. However, astronomers have come up with clever indirect methods to detect the presence of planets around stars. One such method is the transit method. Astronomers keep track of the luminosity of a star over a period of time. If they notice a periodic variation in the star's light curve, it could be a sign that a planet is passing in front of the star, partially blocking its light. This causes a dip in the light curve, providing evidence of the planet's existence. Another method astronomers use is called the radial velocity method. They know that the planet doesn't orbit directly around the star, but instead both the planet and the star orbit around the center of mass of the planet-star system. While the star's movement is minimal, our instruments are sensitive enough to detect these slight movements. This method relies on measuring the changes in the star's radial velocity, or the speed at which it moves towards or away from us. These changes can be caused by the gravitational tug of an orbiting planet. Out of these methods, the transit method is the one that astronomers use to discover Kepler 22b, our fascinating exoplanet. It was December 5, 2011. It caused quite a stir in the scientific community and became one of the most famous exoplanets. Transits are a powerful tool in discovering exoplanets, even if they are located light years away. Instead of directly seeing the exoplanet, we can observe its presence through the dimming of its star's light. By analyzing the graphs of light received over time, known as light curves, we can identify dips in brightness when the exoplanet passes in front of its star. This data from transits allow us to determine various characteristics of the exoplanet. The size of its orbit can be calculated by measuring how long it takes to complete one orbit, called the period. Furthermore, the size of the planet itself can be estimated by observing how much the star's brightness decreases during the transit. Transits also provide an opportunity to study the exoplanet's atmosphere. As the planet passes in front of its star, some of the star's light passes through the exoplanet's atmosphere. By analyzing this light, scientists can identify the different elements present in the atmosphere and study their dispersion. The composition of the atmosphere is vital in determining whether the exoplanet could be habitable for life. Apart from the atmosphere, other factors affect the potential habitability of an exoplanet. The size of its orbit and the temperature of its star can give us insights into the planet's temperature. This information helps us determine if the planet's surface is suitable for life or if it has extreme temperatures that would make life unsustainable. The transit method allows us to infer crucial information about exoplanets. We can determine the planet's size and period and even gain insights into its atmosphere and potential habitability. The temperature is especially important as it determines whether the planet could support life as we know it. Over the course of 9 years, the Kepler mission confirmed thousands of exoplanets and discovered many more awaiting confirmation. This expanded our knowledge about the diversity and structure of exoplanetary systems. The data collected by Kepler has played a significant role in advancing our understanding of exoplanets and their potential for hosting life. Kepler 22b description. Now I must warn you, uncovering information about this celestial body is no easy task. It requires a team of brilliant scientists with diverse expertise and countless hours of data analysis. Sometimes their efforts may lead them astray, mistaking a mere blip for a planet or being tricked by a speck of dust on their instruments. But let's not be discouraged, for in the vastness of space, wonders await us. First, let's talk about its location. Kepler 22b resides in a neighboring galaxy a mere 635 light-years away from Earth. Now, that distance may seem unfathomable to us, but in the grand scheme of the universe, it's merely a drop in the cosmic ocean. Comparatively, the journey to Kepler 22b would span a mind-blowing 3 quadrillion miles. Yes, it's mind-boggling, but it highlights just how expansive the universe truly is. Now let's take a look at Kepler 22b's star. Surprisingly, it's quite similar to our very own Sun. They share the same age and are nearly identical in size. However, when it comes to luminosity, our Sun outshines Kepler 22b's star by a hefty 20%. Imagine a star that is 20% dimmer than our Sun, situated 635 light-years away. It becomes invisible to the naked eye, emphasizing the vital role of technology in our quest for knowledge. Without our advanced instruments, we would have never discovered this distant planet. Speaking of which, let's delve into the intriguing characteristics of Kepler 22b itself. Its radius is a whopping 2.4 times that of the Earth, making it quite different from our home. If we were adventurous enough to venture there, it would take us more than 3 days of continuous flying to traverse between opposite continents in this enigmatic world. Can you imagine the incredible landscapes and breathtaking sights we would encounter along the way? Kepler 22b, a planet bigger than Earth, holds the promise of more space and resources for us humans. Imagine being able to reproduce without worrying about overcrowding. The vast oceans and rivers on this planet could be even more expansive than those on Earth, ensuring an abundance of water for all. In many ways, it seems like an improvement over our current home. But as with everything, there are drawbacks to consider. Living on Kepler 22b wouldn't be a walk in the park. In fact, it might not be possible for us to walk at all. Due to its larger size and stronger gravity, we would be literally squeezed down by its immense force. Our bodies would have to evolve to adapt to this new environment, making us look quite different from how we do now. Think of the strong and towering Na'vi from the movie Avatar. That's how we might appear on Kepler 22b. Unfortunately, the intense gravity on this planet would likely spell doom for the plants we are familiar with. Without the right conditions, it would be hard for life to survive or persist there. However, we must remember that our measurements and understanding of Kepler 22b are not perfect. There could be unknown factors that make this planet more similar to Earth than we realize. Perhaps the gravity is not as crushing as we currently assume. If this is the case, then we might have a good chance of thriving on Kepler 22b. Even with favorable gravity, it remains uncertain and challenging to determine whether this planet could eventually serve as our future dwelling. Nevertheless, there is an encouraging development as scientists have verified its location within the habitable zone, so there's still hope. Kepler 22b's axial tilt. When it comes to finding a habitable planet, scientists have a lot to consider. But one of the most important factors is temperature. Will it be scorching hot or bone-chillingly cold? And what about seasons? These are the burning questions that researchers ask themselves. Two main factors play a role in determining the temperature of a planet. The first is its proximity to its parent star. Let's take a look at Kepler 22b, for example. This distant world is situated 15% closer to its star than Earth is to the Sun. If Kepler 22b were a member of our solar system, it would fall somewhere between the orbits of Mercury and Venus. In other words, it would be a rather inhospitable place. But here's where things get interesting. Kepler 22b's star is actually less luminous than our Sun. This means that even though the planet is closer to its star than the Earth is to the Sun, it doesn't suffer from a deep freeze. In fact, the 15% difference in distance allows Kepler 22b to receive roughly the same amount of energy as Earth does from the Sun. This fantastic revelation is backed by solid data. So in terms of temperature, Kepler 22b might just be in the habitable zone. However, there's a catch. The second factor is the inclination of the planet's rotation axis, which determines whether it experiences seasons. We don't yet know what Kepler 22b's rotation axis looks like. Our own planet Earth has a slightly tilted axis, resulting in seasonal variations. The northern hemisphere basks in warmth during summer but shivers in the cold of winter, while the southern hemisphere experiences the opposite. But what if Kepler 22b has a radically different rotation axis? This mystery adds yet another layer of intrigue to the search for a potential home away from home. Imagine a world so extreme that it rivals the mysterious icy planet of Uranus. Picture this, a planet with an axis of rotation tilted a whopping 90 degrees. This means that one side of the planet would forever be bathed in scorching sunlight, while the other side would be plunged into eternal darkness. It would be a battle of light versus darkness, fire versus ice. The consequences of such a configuration would be mind-boggling. On the illuminated side, temperatures would soar to unimaginable heights, making it a searing inferno. On the shadowy side, temperatures would plummet to bone-chilling lows, rendering it an icy wasteland. Life as we know it would struggle to survive, yet alone flourish. The only feasible option would be a thin strip of land between these two extremities, a tiny refuge where life could eke out its existence. It would be a claustrophobic prison, far from the idyllic paradise we seek. Thankfully, scientists believe that this extreme axis configuration is a rarity. Most planets, like our beloved Earth, have a lower inclination axis. It's only those unfortunate planets that have endured turbulent histories, encountering cataclysmic collisions that end up like Uranus. These collisions can dramatically alter a planet's axis, condemning it to endless days or nights. Let us remain hopeful that our exoplanet, our potential Earth 2.0, does not share Uranus's fate. Pray that it spins on its axis like a well-behaved celestial body, making life's journey easier. We yearn for a place where life can flourish, where light and darkness dance harmoniously, not a world torn between eternal extremes. Hey, before moving on, be sure to like or dislike the video so that we can improve them for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. Water on Kepler 22b. Water is a crucial element for the development of life, and its presence on the exoplanet Kepler 22b is a significant factor to consider. Recent studies suggest that Kepler 22b may have a vast ocean, the extent of which is still unknown. Whether it is a small ocean or one that covers the entire planet, the presence of water makes it more favorable for the existence of life. Oceans play a vital role in sustaining life on Earth by providing food, regulating the climate, and producing oxygen. Furthermore, they contribute significantly to the world's economy, supporting industries such as tourism, fisheries, and international shipping. However, it's not just the presence of water that determines a planet's suitability for hosting life. The way oceans are formed also plays a crucial role. Oceans are dynamic habitats, and some may be more conducive to supporting life compared to others. On Earth, the circulation of the ocean transports essential nutrients like phosphate, which are necessary for the distribution and productivity of marine life. Upwelling, a process where nutrients from the deep ocean are brought to the sunlit regions, is particularly important for the thriving of photosynthetic organisms. The dynamics of the ocean impose constraints on the activity and atmospheric expression of photosynthetic life, and it remains unclear how these dynamics might differ on other planets. Understanding the dynamics of ocean systems on exoplanets is a key aspect that scientists will need to address in the future. Further research in this area will contribute to solving the puzzle of life beyond Earth and advancing our understanding of the universe. The presence of water on Kepler 22b, potentially in the form of a vast ocean, increases the likelihood of the planet being habitable. However, in order to speak of Earth 2.0, it is essential to consider not only the presence of water, but also the dynamics of the ocean system. Satellites on Kepler 22b. The moon presence has a noticeable impact on tidal forces. On Earth, its gravitational pull creates tides in the oceans. These tidal movements create dynamic ecosystems along the coast, providing a home for diverse forms of life that have adapted to these fluctuating conditions. In contrast, if a planet didn't have a moon, there would be no tidal forces, resulting in more stagnant oceanic environments. This lack of tidal zones could hinder the development of different habitats, potentially limiting the range of species that could evolve. Another important aspect is the stability of a planet's axial tilt, which directly affects its climate. Thankfully, moons help maintain this stability by exerting gravitational forces that would regulate the variation of the planet's axial tilt over time. A planet without a moon would experience more extreme and unpredictable changes in its axial tilt, leading to erratic and harsh climate conditions. On the other hand, a planet with a moon would enjoy a relatively stable axial tilt, creating a milder and more predictable climate. This stability is crucial for the evolution and adaptation of life forms. So even though we don't know if Kepler 22b has a moon, we can understand the significance of the moon for life on Earth. Its influence on tidal forces and its role in stabilizing the planet's axial tilt have shaped our oceans and climate, providing the conditions necessary for life to thrive. The moon truly is a romantic satellite that has played a big part in the development of life on our amazing planet. As you can see, there are numerous factors that make a satellite vital for the evolution of life, and one intriguing aspect is also its effect on a planet's rotation rate. The gravitational dance between a planet and its moon can orchestrate mesmerizing changes in the planet's spin. For example, our very own Earth experiences a gradual deceleration of rotation over millions of years, leading to a lengthier day-night cycle. This elongated rotation period introduces a harmonious equilibrium, moderating temperature fluctuations between night and day. Such a stable thermal environment serves as a nurturing cradle for life to flourish. However, if we were to imagine a planet devoid of a moon, we would plunge into a world of high-speed rotation, triggering extreme temperature oscillations that would pose formidable challenges to the development of complex organisms. These captivating insights only intensify our yearning for the enigmatic exoplanet Kepler 22b to possess a moon. Alas, current technological limitations hamper our ability to confirm its lunar companion. Detection of a moon around an exoplanet remains an arduous task, as the feeble signals emitted by these celestial bodies are notoriously elusive. Nevertheless, the rapid advancements in technology raise hopes that future endeavors will uncover the long-awaited lunar presence around distant planets, including Kepler 22b. The prospect of finding a moon orbiting this exoplanet beckons like a tantalizing puzzle, promising thrilling revelations about the universe we inhabit. Birthdays on Kepler 22b. On the planet Kepler, birthdays happen every 9 months, because that's how long it takes for the planet to orbit around its star. Surprisingly, this is similar to the time it takes for Earth to orbit the Sun. To figure out the period of an exoplanet, scientists just need to look at the velocity curves that are created over a few months. When the planet passes in front of the star, it blocks some of its light, creating a dip in the curve. Observing when and how often these dips occur, scientists can determine the planet's period. But here's the exciting part. Changes in the measured period of an exoplanet can actually tell us if there are other planets nearby. Imagine that there's a big planet like Jupiter in the vicinity of Kepler 22b. This planet would attract and be attracted to Kepler 22b. These interactions would cause perturbations or disturbances in Kepler 22b's orbit, resulting in a slightly different period. Luckily, astronomers are really good at measuring small variations in time, down to a few seconds for most exoplanets. It's pretty mind-blowing, right? This technique is called transit timing variation, or TTV, and the name says it all. Kepler 22b's composition. One of the most tantalizing questions is the composition of Kepler 22b. Unfortunately, our current technological limitations prevent us from obtaining any concrete answers. Taking a direct picture of this distant world is impossible, as it would require an unimaginable 635 years of travel at the speed of light. However, based on what we know about the universe, we can make educated guesses about the planet's composition. For life as we know to exist, Kepler 22b would need to be a rocky planet. If it were a gaseous planet, the smallest known gas dwarf, in fact, the chances of supporting life would be non-existent. The laws of nature simply don't allow life to thrive on such a planet. But what if Kepler 22b is something entirely different? What if it is an ocean world, similar to the mesmerizing setting of the movie Interstellar? In this scenario, humans could potentially build floating cities on the planet's vast oceans, adapting to an amphibious lifestyle. This would provide a unique opportunity for life as we know it to flourish. Perhaps the most thrilling possibility is that Kepler 22b is a rocky planet, much like our own Earth. This would present an incredible case of Earth 2.0, offering a glimpse into what our planet might have been like billions of years ago. However, even if it is a rocky planet, one crucial detail remains unknown: whether it possesses an atmosphere or not. The atmosphere is like the unsung hero of habitability. It may not get as much attention as the breathtaking landscapes or the mysterious oceans, but without it, life as we know it would be impossible. Allow me to enlighten you on the captivating role that an atmosphere plays in creating a welcoming environment for living organisms. One of the most crucial functions is the ability to regulate a planet's temperature. Imagine a world without temperature stability, where scorching hot days are followed by bone-chilling nights. Sounds like an inhospitable nightmare, doesn't it? Luckily, the atmosphere swoops in to save the day. By trapping heat through the greenhouse effect, certain gases like carbon dioxide and methane create a cozy blanket for the planet. This prevents extreme temperature fluctuations and provides a stable climate that is conducive to life flourishing. But that's not all. The atmosphere shields the planet's surface from the harmful onslaught of cosmic and solar radiation. Picture the damaging effects of ultraviolet rays on our fragile DNA. Without an atmosphere to filter out or absorb this harmful radiation, complex life forms would struggle to develop. Think of the atmosphere as our very own cosmic sunscreen, protecting us from radiation that could otherwise be catastrophic. Another mesmerizing aspect of the atmosphere is its ability to maintain liquid water on a planet's surface. You see, the pressure exerted by the atmosphere is essential for the existence of liquid water. And as we all know, water is the elixir of life. Without the right atmospheric conditions, water would either evaporate into thin air or freeze into solid ice. Our hero also determines the availability of essential elements like oxygen, carbon, and nitrogen, which are the building blocks for organic processes. It's like a delicate dance where the atmosphere ensures that the right ingredients are there for life to thrive. As we ponder the possibilities, we realize that we know very little about Kepler 22b's atmosphere. It could be like the barren atmosphere of Mars, incapable of retaining heat and subjecting the planet to extreme temperature swings. Or to our dismay, it could resemble the thick, toxic atmosphere of Venus, with its oppressive heat and sulfuric acid clouds. Either scenario would render Kepler 22b inhospitable for life as we know it, dashing our hopes for extraterrestrial neighbors. But don't despair, because Kepler 22b might possess an atmosphere akin to Earth's, which would bring great joy to all humans. The only task left would then be figuring out the quickest way to reach it. That's all for this video. Thank you so much for watching. Do you think we will ever find Earth 2.0? Let us know in the comments below. We'll see you next time on the channel.